In our normal day-to-day life, the minimum amount of work that you can do is 0. If you just lie around doing nothing, you do 0 work. That's the least you can do, right? But in physics, you can do even less work. That's right, you can do work less than 0 in physics. Let's find out how. Now, in a previous video, we saw how to calculate work. It's calculated as force acting on an object multiplied by the displacement of that object. This means that to do work in physics, you need to push or pull on something, and while pushing or pulling, you have to make it move. This is how we do work in physics. Now, here's the thing. This work done can be both positive and negative. Okay, so let's quickly find out when it's positive and when it's negative. To do that, let's make some space. So let me write this in short form. We'll just write as W equals F into S. F is the force, S is the displacement, and let me get rid of this. Excellent. Now, if the force and displacement happen to be in the same direction, that's when we say work done is positive. It's a positive number. On the other hand, if the force and the displacement happen to be in the opposite direction, and we'll look at some examples, then we'll say work done is negative. This is when work done becomes smaller than 0 because a negative number is smaller than 0. So let's look at some examples. Suppose a lady is pushing on a grocery cart and makes it move. Then she is doing work on it because she's pushing on it and she's making it move. Now, is that work positive or negative? Well, let's see. If you look at the direction of the force, she's pushing it to the right. And look at in what direction that cart is moving. It is moving in the same direction, to the right itself. So here the force and the displacement are in the same direction, and therefore here she's doing positive work on that cart. So the work done over here is positive. On the other hand, imagine an uncontrollable car that is being stopped by Superman. Now let's think about the work done by Superman on the car. Let's see if this is positive or negative. Okay, let's look at it one more time. So here's our Superman, and here's the uncontrollable car. The moment Superman starts pushing on it to try and stop it, he puts a force on it. What direction is Superman pushing on this car? Well, from here you can kind of see he's trying to slow down that car. It's pushing on it towards the right. Okay? But what direction is that car moving? Well, the car is moving to the left. As it's being stopped, notice the car is moving to the left. So notice the force on the car is to the right, but it's being displaced to the left. So the force and displacement are in the opposite direction. So over here, Superman did negative work on the car. Now here's where it sounds a little weird. If you look at some people who might be just standing and watching this show, they did absolutely nothing, so they did 0 work. Yet Superman, who saved the day, did negative, less than 0 work, which means Superman, strictly speaking, did less work than these people. How does that make any sense, you may ask? Well, that's how it is. It's mostly because work done in physics can mean very different thing compared to work done in our day-to-day life. Okay, you try one. Imagine you play catch and a ball is thrown and you catch that ball. In that case, you are doing work on that ball because you are putting a force on that ball and the ball is moving. Can you think about this, whether the work done by you on that ball, is it a positive work or a negative work? Go ahead, pause the video and think about this. Here, let me show you one more time. So here's the ball and you catch it. All right, let's see. So as the ball comes towards you, the moment you make contact with the ball, you start pushing that ball. Now, in what direction are you pushing? Look at where your hand is placed. You're pushing that ball towards the left, isn't it? That's what you're doing. But in what direction is the ball moving? Both the ball and your hand are moving back, right? They are moving back as you stop that ball. which means, notice, the force on that ball is to the left and the ball moved to the right, so the force and displacement are in the opposite direction, which means while catching that ball, you did negative work on that ball. Okay, you can try another one. Imagine we take a ball and we throw it up. Let's say we throw it up and consider the upward motion of the ball. Now, during this time, gravity is putting a force on that ball, right? So can you think about the work done by gravity during the upward motion of the ball? Do you think it's positive work or negative work? Again, have a look at it one more time. We're throwing the ball up. Just concentrate on the upward motion of the ball. Again, pause the video and think about this. All right, let's see. So what direction is the force of gravity acting? Well, gravity always acts downwards, right? So the force of gravity is downward, but the ball is moving up. So notice that the force and the displacement are in the opposite direction. That means during this motion, gravity is doing negative work on that ball. It's the force is due to gravity, right? So it's gravity who's doing work. So gravity is doing negative work during the upward motion of the ball. On the contrary, what would happen if you were to throw a ball down, or if you were to drop a ball? Well, if you were to drop a ball, I'm now pretty sure you can agree. Again, the gravitational force would be downwards because gravity always acts downwards. And notice now, the displacement is also downwards. So when a ball is falling down, this time gravity is doing positive work on that ball. Now, before we wrap up, you may be wondering, why is it defined this way? What's going on? Well, to get some insights, that's because when the force and the displacement are in the same direction, objects tend to speed up. And when the force and displacement are in the opposite direction, objects tend to slow down. So they have opposite effects. To give you an example, when the ball was falling down, the force was in the same direction as that of the displacement. The ball speeds up. When you drop things, they become faster and faster as they go down, right? On the other hand, when we threw the ball up, when the force of gravity is in the opposite direction of the motion, what happens to that ball? It slows down, isn't it? So notice here, this has opposite effect of this. And to denote that, we call this work as positive when the speed tends to increase, and we call this work as negative when the speed tends to decrease. But as of now, don't worry too much about this because we'll get more clarity on this once we start connecting work and energy. Then it'll start making more sense, okay? So what did we learn in this video? We saw that when the force and displacement are in the same direction, we call the work as positive. In the opposite direction, we call the work as negative.